Binomial expansion is when you use combinations and a combination formula to multiply binomials together, things like a plus b to the fifth power. Once we can do that, we can use that expansion to do some calculations coming up later. First thing I want to show you is that if you take like x plus 1 times x plus 2 times x plus, just make it 4 times x plus 6. If I multiply that out, it becomes some big polynomial. I want to show you how to find individual terms of that. Remember FOIL, x plus 1 times x plus 4, let's say, and you did the first to get x squared, and the outers to get 4x, and the inners to get 1x, and the last to get 4, and then you combine like terms. Well, the same thing happens when I'm multiplying a whole bunch of binomials together. Each term that comes about, in this case there's 4, in this case maybe 16 terms. Each term would be would use one thing from each parentheses. For example, I could use this x with this x with this x with this x to get x to the fourth. Or I could use, to use a different color, this x with this 2 with this 4 with this x to get x2 4x is 8x squared. Or I could maybe use the 1 and the x and the 4 and the 6 to get 1 times x times 4 times 6 is 24x. And there'd be a whole bunch of, maybe 16 of these terms also. Some of them would have x to the fourth, some would have x squared, some would have x, and eventually they'd all get put together into 5 terms, ones with x to the fourth, ones with x to the third, ones with x squared, ones with x, ones that are just constants. I want to show you how we can work out individual terms of this. I'm going to erase. So for instance, imagine I want to know what's the x cubed coefficient. I'm going to write out, to get an x cubed, I need 3 x's and one number. So for instance, I could do x, 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 6. I'm even going to write that. Or I can do x, x, 4x. Or I can do x, 2xx. Or I could do 1x, x, x. This is 6x cubed, this is 4x cubed, this is 2x cubed, this is x cubed, and altogether it becomes 13x cubed. So I can get individual terms using that sort of method. Now sometimes it's just x plus 1, x plus 1, x plus 1, x plus 1. I have 4 of these. Just throw in a 5th one. So now if I want to know the x cubed term of this one, I could do x, 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 1, 1. Or I could do x, x, 1, x, x. Sorry, 1. X, x, 1. Yeah. X, x, 1, x, 1, sorry. I could do x1, x, x1. See, I'm choosing the x from the first, the 1 from the second. I could do 1, x, x, x1. There's going to end up being, here's some more. I could have that, or I could have 2 x's here. Notice I found 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ways. Well, that 10 could have been calculated out by treating it a bit like the ice cream problem from an earlier lesson. There are 5 things I need to choose, and 2 of them need to be 1s, and the rest aren't. So which 2 are going to be 1s? Well, that can be calculated 5C2. And 5C2 is 5 times 4 over 2, which is 10. That gets you right to the answer. This means that if I want to expand x plus 1 to the 5th power, there's going to be an x to the 5th term, an x to the 4th, an x to the 3rd, an x to the 2nd, an x, and 1. And the x cubed is going to be 10, because that's 5C2. For x squared, it's going to be 10 also, because that's 5C3. For the x, for the 5x, it's going to be 5C4. If we want, we can call this 5C5. In front of the x to the 4th is 5C1. And in front of the x to the 5th is 5C0. So using combination numbers, we could expand things. One thing we can do with this now, something that maybe seems a little bit, and more generally, if I raise something to a power, the variables are going to go like this. The a's are going to the power on the a is going to go down. The power on the b is going to go up. Always going to add up to 5. And the coefficients are still going to be, if there's a 5 up here, it's going to be 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. This can be used to do a kind of, somewhat of an interesting kind of problem. I want to know 4 to the 4th power. Well, we know it's 256. 4 times 4 times 4 times 4. But an alternate way to do it would be to rewrite 4 as 3 plus 1, and then do the binomial expansion on that. It's going to be 3 to the 4th, 1 to the 0. There's going to be some number out here. We'll leave that for later. 3 to the 3rd, 1 to the 1st. 3 squared, 1 squared. 3 to the 1st, 1 to the 3rd. And then 3 to the 0, 1 to the 4th. The coefficient is going to be 4C0, which is 1. 4C1, which is 4. 4C2, which is 6. 4C3, which is 4. 4C4, which is 1. And when you put these all together, the first term becomes 81. This becomes 27 times 4, which is 128. The next term becomes 6 times 9, which is 54. The next term is 4 times 3, which is 12. The next term becomes 1, and when you add those together, again, you get 256. Well, it seems like a silly way to raise 4 to the 4th power, but it will come in handy in the next lesson.